Hi, so this is a quick discussion following our TA meeting for question one, for question homework 7, question one. We tried to solve this during the TA hours, and I believe that the answer we got overcomplicated things, made things like not clear, despite this should be a very straightforward question. So the first step is to get h of j omega, which is V out over Vn in our three cases. When V out is Vr, when V out is VL, and when V out is Vc. So I wrote the three cases. Then for each of the three cases, we're gonna solve for three values of f. So for case one, when V out equals Vr, let's make f equals to 0. So when f is equals to 0, this means that omega is equals to 0. So the impedance of my inductor is low and the impedance of my capacitor is high. In other words, my inductor is a short circuit and my capacitor is an open circuit. So no current is passing. So there is no voltage difference across VR. So VR equals 0. VR over Vn equals 0 over, like no matter what Vn is, over Vn equals 0. So magnitude of 0 is equals to 0. At my second case, f equals 2k. So this means that omega equals 4 pi k. So we just substitute the value for omega, substitute the value for R, L, and C, and it's a straightforward answer. For my third case, at f equals infinity, during the class, we try to solve for the magnitude of the numerator and the magnitude of the denominator divided by each other, get infinity over something, but like this is an overcomplication. So we just need to think about it. So as f equals infinity, this means that omega is equals to infinity. So the impedance of my inductor is open. So no current is passing, like this part is open, of the circuit is open. So no current is passing. So no voltage difference between those two elements. So VR over Vn equals 0. VR is equals to 0. Like it's not a complicated question. Unfortunately, I gave an impression that it might be. For the second problem, exactly the same thing. At f equals 0, the omega is equals to 0 as well. So this part, my inductor acts like a short circuit. So there is no voltage difference in a short circuit. So VL over Vn equals 0 over Vn equals 0. And at F equals 2K, VL over Vn, yeah, same thing. So omega equals to 4 pi k. We'll just substitute, we'll get a value, and we'll get the magnitude of h of j omega. So it's a value. You just like get h of j omega and solve for the magnitude of h of j omega. Straightforward problem. And at f equals infinity, same thing. So my inductor, the impedance of my inductor is 0. So this means that there is no voltage difference. Sorry, the impedance of my inductor is an open circuit. So this means that the voltage difference of my inductor is equal to the voltage difference between Vn. So in other words, VL over Vn. So VL equals Vn. So VL over Vn equals 1. So that's it. Like you don't really need to solve it. Third case, at f equals 0. So the impedance of my capacitor, not like the impedance of my capacitor x of c equals 1 over j omega c. So as omega equals 0, x of c equals infinity. So the impedance of my capacitor is open. My impedance of my capacitor is infinity, so it acts like an open circuit. This means that the voltage across the capacitor is same as Vn. So Vc over Vn equal Vn over Vn equals 1. And at f equals 2k hertz, we will solve for h of j omega. And at f equals infinity, so the opposite will happen. The impedance of my inductor will be very high, while the impedance of my capacitor will be a short circuit. Voltage across a short circuit is voltage difference across a short circuit is 0. So so Vc over Vn equals 0 over Vn. We don't need to solve for anything. Equals 0. If you don't trust this process, and I don't, I'll simulate it in MATLAB, and maybe we'll have like, or you can simulate it in MATLAB or simulate it in whatever software you prefer and see if you get the same values or not. But like, this is a very simple problem if you think about it. Thank you.